All right, so we have talked about some integration techniques. Yesterday we looked at U substitution. Today we're going to put this back with the fundamental theorem of calculus. So we've used the fundamental theorem of calculus with our integration graphically and literally found the areas under the curve. So now we're going to do these where we really wouldn't find the area under the curve because we don't have a curve. Yes, we could graph it, but we wouldn't be able to find that area accurately anyway. So we're literally going to integrate. So we're going to start with this first one that does not have any limits of integration. This one, this is what these are, your limits of integration. Okay? So if you remember, fundamental theorem of calculus, what we saw was the integral from a to b of f prime of x dx is equal to f of b minus f of a, right? So if I take if I integrate it, then I can find these two values and subtract. And then this is just some other notation you'll see in there in just a little bit. So this first one, we don't have any limits of integration, so it's just kind of a review from yesterday. So let me give you a minute, and I want you to, this is not new. This is what we were doing yesterday and the day before. So see if you can integrate that. Maybe. You may not have to use a U substitution. Oh, I said yesterday, but yeah, with the integration we've been doing. You don't need a U substitution on this one. Just a regular old integral. Come on now. Yes, and because they're, okay, so let's talk through this. One of our properties of integrals is that I can say the integral of this plus the integral of this plus the integral of this. So I can integrate these since they are in separate little terms. Each is a separate little term. Okay, you might want to how could we rewrite this one? 5x. Yeah, I would rewrite it as 5x to the negative 4, and then you just integrate each piece. Don't make it harder than it is just because it's an integral. You got this. Let me walk you through it. So if I'm going to integrate this step by step, when I integrate this term, I'm going to add 1 to the exponent, so that becomes 3x cubed, and then I divide by my new exponent. Plus 5x to the, I add 1 to the exponent, so that's negative 3, divided by my new exponent. Plus, so when I integrate sine, what do I get? Negative cosine. Remember what Miss Bruce wrote up here yesterday, and I really liked it because I hadn't seen this before. Yeah, I did. So here's this. If we're going to take the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine, right? And so if I'm going backwards, the integral of negative cosine is negative sine. Negative sine is cosine, right? And so forth and so on. You see how that works? So I'm integrating sine, of course I can't go up. If I go up, it's negative cosine right there. Kind of makes a little circle. So this is, I put plus, but I'm going to rewrite it anyway. So I'm going to put plus negative 2 cosine of x. And then what do I have to have? Plus c. Okay. So then when I clean this up, those three, I mean, you can leave it. That's a safe stop, and it's totally fine. But x cubed, then minus 5 over 3x cubed. Right, minus 2 times the cosine of x plus c. Okay. We good with that? All right. Any questions? All right, so let's see what we do when we have limits of integration here. So I'm going to integrate this, right? So I'm going to integrate this, and I'm going to add 1 to the exponent, so this is x cubed, divided by the new exponent, plus 4x, right? Then what? Plus c. Okay. Then I am going to evaluate it from the limits from 1 to 3. This is where your fundamental theorem of calculus comes in. if this is f prime of x, this is f of x, okay? So that means that when I integrated it, that is equal to this function evaluated at 3 minus the function evaluated at 1, right? That's what this is saying right here. We integrate it like we just did, and then that integral is going to be equal to the function evaluated at b, the top, minus the bottom. So I'm going to substitute in the 3. When I do that, I get 3 cubed. I'm just going to write it down like this first. Divided by 3 plus 4 times 3 plus c. You with me? I was substituting in that 3. Then I subtract, and I'm going to do parentheses because I have more than one term, when I substitute in the 1. So that's going to give me 1 cubed over 3 plus 4 times 1 plus c. You with me on that? Okay, so 3 cubed is 27 divided by 3 is 9 plus 12 plus c, then minus 1/3 minus 4 minus c. Yep, the c's zero out, right? Positive c and negative c. So this is going to give me 21 minus 4. What's 21 minus 4? 17. So that's going to give me 17 minus 1/3. So that is 16 2/3. You can leave it like that. It's okay that it's not a mixed number. Don't ever try and substitute in a mixed number anywhere, though. That's one reason why we kind of don't let you do them for so long, is because you'll try and do weird things with them. If you were going to substitute that in somewhere, make it into an improper fraction, okay? Now, look at what happened here. We took this evaluated at some number minus this evaluated at another number. So anytime we have something that we have integrated, this part's going to change, but we'll always have a plus c, right? So do you see how I have a plus c here, then I end up subtracting it? Would you agree that that's going to happen every single time? Then one of them would be negative, so they would still zero out. That's a very good question. It would still zero out, and you'd be fine. Okay? Does that make sense? So every time, since I'm going to add it to this, whatever c is, and then subtract it from this, it's going to zero out every time. So when you integrate and you have limits of integration, you don't have to have the c. Okay? I wanted you to see one where this happens. It would happen every single time, so it's acceptable, but be careful not to leave it off when you don't have limits of integration, because then you're going to be wrong. You with me on that? So if you're leaving it as you're going to leave it as an equation in the end, it has to have that plus c. If you're going to use that equation, then you're okay with it not being there. You with me? Okay. So let's try this one. So I have a product here. Is there a product rule for integration? No. So what do we want to try? U. What do we want to try as our u? X cubed, okay? So u equals, so the inside of the parentheses, right? U equals x cubed plus 1. So that means du is equal to 3x squared dx. Okay. You with me on that? All right, so that means that when I do this, I need a 3 in here to get my 3x squared dx, and I need a 1/3 out there, right? Okay, so I'm going to go 1/3, and I'm going to integrate. So this is all gone. I just have u squared. Now, our limits of integration, which I wrote over and I can't even read on there. It went from 1 to 2. That's when it's x. We are integrating u. These numbers will change, most likely. I mean, it's possible that something could stay the same. But I'm using u's here and not x's like I did here. It's from this means from when x goes to 1 to 2. Well, now I have u's. So we need to say that when x equals 1, because that's our lower limit there, when x equals 1, what is u going to equal? Look, here's my u. So yeah, so 1 cubed plus 1, which is 2. Right? I'm just substituting it in. That's all I'm doing. when x equals my other limit, which is 2, be 2 cubed plus 1, which is 9. So since I have changed from x's to u's, instead of going from 1 to 2, I'm going from 2 to 9. And I have to have my du on that. You with me on that? Okay, and it's actually going to make things a little bit easier in the end. Because now when I integrate, I'm going to have 1/3 times u cubed divided by 3, right? I can leave off my plus c because I'm about to evaluate it. And I'm going to evaluate, and if you can rewrite it or you don't necessarily have to. I'm going to rewrite this as 1/9 times u cubed. You can kind of do that together in one step. Actually, I shouldn't have equals there. This is going to change to this little arrow instead. Evaluated from 2 to 9. Okay, I'm using the limits of integration. I'm using u, so I can use these. I don't have to substitute my x back in there. It actually keeps me from doing a lot of extra work, right? Squaring a number, adding 1, and then or cubing it, and whatever. So when I do this, do the top minus the bottom. So I'm going to have, that's going to equal 1/9 times 9 cubed minus 1/9 times 2 cubed. All right, do I actually have to cube 9? No, because 9 cubed over 9 is just 9 squared, right? What's 9 squared? 81, so I get 81 minus what? 8 over 9. We can leave it like that, right? It's a safe stop. Or this does become 80 and 1/9. It does become 721 over 9. So if it was multiple choice, any of those could be, your answer. But what questions you got? Yes, sir. When you can't just straight up do one of the 9 you know. If you can't do the power rule, it's not trig, and it's not going to be the 1 over x where it's natural log. So like here, I didn't need to. I mean, technically, I could say u equals 2x squared, but then that would give me 2x when I took the derivative, and it actually wouldn't work. There's no need to, because I can do it term by term. Here, because I have a product and I have no product rule, or if I had a quotient and I have no quotient rule, that's going to kind of be your general time. Like once you try to do this without u substitution, you're going to realize you can't do anything, so then that's when you would try that. Does that help? Ask me another question. That's fine. You tell me, you stop me in the middle of another one if you have like another way to kind of phrase what you're confused about. Okay? Anybody else have anything? Okay. So let's look at D. Is D, okay, here's the other thing. It's when you have a composition of functions. Composition of functions doesn't mean two functions added together. It means really a function inside of a function. So if I have a function inside of a function, that's your composition of functions, or if I have a product, then I'm going to have to do that. Here, do I have a function inside of another function? I do. What is it? 3x. 3x is a function. It's inside the sine function, right? I can't, because if I was to take the derivative of something like this, I'd have to use the chain rule, right? So since I would have to use the chain rule, then I have to, when I go backwards, there is no chain rule for going backwards, okay? So in this situation, I can't just say that this is going to be negative sine of 3x because there's a function inside of there. So I would have to use u substitution. What would my u be? 3x, okay? So then that means du is equal to 3 dx. So I have to multiply my 3 in here, which means I have to have a 1/3 out there. Right? And I also am going to change from x's to u's, so I have to say, well, when x equals 0, then u equals, so I substitute x into here, and I get 0. When x equals pi sixths, u equals, well, I take pi 6, I multiply it by 3. What does that give me? Pi halves. So that means I'm going to have 1/3, and I'm going to integrate from 0 to pi halves of the sine of u du. Okay. All right, we good? So when I do this, 1/3, when I integrate sine, what do I get? Negative cosine. So this is going to be negative 1/3 cosine of u. And then I don't need to do the plus c, right? I mean, if you do, it's fine. It's just going to zero out. I'm going to evaluate that from 0 to pi halves. So I evaluate the top and then subtract evaluating the bottom. So this is going to give me negative 1/3 times the cosine of pi halves minus a negative 1/3 times the cosine of 0. What is the cosine of pi halves? 2. 0. Did you say 2? Oh, I thought you said. Oh, okay, I thought you said 2. I was like, 2? Get out of my room. Where'd you get 2 from? It's 0. Okay. So I get negative 1/3 times 0, which is 0. So I don't even need to write it. Then I have a negative negative, so that becomes a positive 1/3 times, what's the cosine of 0? 1. And that gives me 1/3. Yes, from where? Where am I rewinding to? Here? When I put down the 1/3. Okay. So the cosine of pi halves is 0. Do we agree with that? Okay. So really I could put 0 here, 0 plus. So all this becomes 0, right? Then so then this is a negative times a negative, that becomes a positive, right? Here's my 1/3. Cosine of 0 is 1. So then I do 1/3 times 1, which is just 1/3. You good? Awesome. Anything else? Something else. What's this next question? What do we mean? Oh my goodness. When you have a sine cubed, what should be the first thing you do? We rewrite it, absolutely. So 0 to pi over 20 times the sine of 5x cubed times the cosine of 5x dx. Totally rewrite it. There's a lot of things that wouldn't kill you to rewrite so that you don't think about it weird in your brain. All right, so do we need to do u substitution here? Yes. For sure. What's going to be our u? Sine of 5x. Very good. So u is equal to the sine of 5x. So du is equal to, is it negative? It's a regular because we're taking the derivative. So when I take the derivative, 5 times the cosine of 5x dx. Okay. And then let's go ahead and take care of our limits. So when x equals 0, u equals, well, 5 times 0 is 0. What's the sign of 0? 0. When x equals pi 20ths, u equals, all right, well, pi fourths. You're like, oh crap, pi 20ths. No, it's going to work out nicely.
Square root of 2 over 2?
Yes. Look at you. I put it in front, but yes. Sorry, I was conditioned to always put those things in the front, so it bothers me when it's not. No, it's okay. I can go through the logic. It's just I feel like my teacher is like yelling at me in the back of my head. Just like I hope to traumatize y'all one day. All right, are we good so far? Everybody with me where everything came from?
Yes.
We sure? Okay. Because 5 times pi over 20 is pi fourths, and when we substitute it in, that's why we get square root of 2 over 2. Okay, so now we come over here, and I've got to add a 1/5. Yes, because I have 5 cosine of 5x, so I need a 5 in here. So I get all of that, so that means there has to be a 1/5 out here. So 1/5 times the integral from 0 to square root of 2 over 2 of, all of this is gone, so I just have, and this becomes u cubed du. So this equals 1/3. Then I take u to the 4th. What am I doing? Oh, 1/5. We're making stuff up. I have no idea where that came from. Thank you very much. All right, 1/5. Seeing if you're paying attention. Proud of you. Times u to the 4th divided by 4. Right? All right, and I'm going to evaluate that from 0 to the square root of 2 over 2. So let's start with the top. Are y'all okay with me taking this and making this 1 over 20? Yes. Yes? Okay. So this is going to equal 1 over 20 times square root of 2 over 2 to the 4th power. Yes. Yes, because when x is equal to pi 20, so yes, that's why I've changed it from this to this. And this is what I'm substituting in. You always go to the top to the bottom. I'm substituting it in for you. You don't put sine 5x. No, we don't have to put it back in. So when we did u substitution and we were doing indefinite integrals, we didn't have limits of integration. We did have to substitute it back in and do all that stuff. We could, and then we could do the x's, but it's just going to be a whole lot more work. Okay? So we're just stopping at the u part. So then I have 1 over 20 times, that's 0 to the 4th over, that's just times 0. Right? Any questions about where anything came from? Are we good over here? Ask me a question. You sure? I've watched you here too, though, I can tell. Are you sure? Okay. Do you understand where this came from? Do the sine of pi force? Okay. And do you understand what I did here?
Question she had. Why is square root of 2 over 2?
Okay, because our limits of integration went from 0 to pi over 20, right? Okay, that's when I had the x's in there, right? We changed from x's to u's. That's why we did this over here. So instead of going from 0 to pi over 20, we have 0 to square root of 2 over 2. Those are our limits of integration. And our limits of integration, once we integrate, that's what I'm evaluating here. You with me on that? We good? Okay. So now, I'm going to have 1 over 20 times, all right, anything to the 4th power, you just square it and square it again, right? What's the square root of 2 squared?
4 over...
Now, answer my question. What's the square root of 2 squared?
2.
2. Square root of 2 squared is 2. And then 2 squared is 4. Okay. Then 2 squared is 4, and 4 squared is 16. Okay? Yeah, 1 over 20 times 4 over 16. 4 over 16 is just 1/4, right? So you get 1 over 80. How did I do what? The square root of 2 squared? Oh, because 4 over 16 is 1/4. Oh, that's fine too. It's fine. Lots of ways to do it. What I would not do, I mean, you can, but it makes it hard. Multiply straight across, then reduce. You could do that. That'd take me a lot longer too. Yeah, no. Try and reduce first. What questions do we have? Are we good? Okay. So now you were skipping things. You make me mad. All right, let's look at this one. What is this? Okay, so I have the integral from -2 to 5 of f of x dx equals 4. I want to find the integral from -2 to 5 of 3f of x minus 2 dx. So this is where we're going to use some properties of integrals. Okay, because I need to find this, but all I know is this. I need to split this thing up here. Okay, so I can split this up by subtraction. That's a rule that's one of the things we're allowed to do. So I could say the integral from -2 to 5 of 3f of x dx minus the integral from -2 to 5 of 2 dx. Do you agree that that is the same thing as what we had written? Well, it's not literally the exact same thing, but it means the same thing, right? I just split it into 2. What can I do with this 3? Can I factor it out? That's legal, right? So I can say this is equal to 3 times the integral from -2 to 5 of f of x dx minus the integral from -2 to 5. Oh, do what the same thing? What? Well, you could, but you don't need to. It would be weird. I think you'd make things up if you did. That's a good question. I wasn't even thinking about doing it that way, but you're right. You could. Then you'd have a 1 there, and then. But I feel like sometimes when you'll end up with zeros and ones, you make it way harder and you make up stuff, and that's what I'd be a little afraid of. Okay. Everybody with me on why all of that is legal? Okay.
Give me 5 seconds.
Yes. To process. All we did was take this, and one of the rules that we have, so for instance here, we could have written this as 3 different integrals added together. Like we could have rewritten it, split it up that way. We just didn't because we didn't need to. Here we need to, so because it's a totally different kind of problem. So I'm just taking this, and all I did was split it into 2 different integrals. That's it. My next step, all I did was factor out this constant because that's allowed as well. A pencil and a calculator in your brain and be on time. Noon. Noon 30. You get there. So there's 2 sessions. Then in between the second and third, there's a 10-minute break. You get a snack and I think a water bottle. That's not provided. I'm providing breakfast, but that's provided by them. And then the prizes and stuff are given away at the end, like the last 15 minutes or so. I think so. I don't know what all is going to be there. So, all right. Are we all good with where all this came from? Now let's think about what we know and what we're looking for. We know that the integral of f of x equals 4. That's what this is right here. Yes? I should have used a different color.
Oh, yeah.
This is this. Do you agree with that? So if it equals 4, then I have 3 times, instead of this, 4. Minus, do you remember what we do when we integrate a constant? 2 times the change in x. What's the change in x? 7, because I go from -2 to 5, so that change is 7. So minus 2 times 7. So that gives me 12 minus 14, which is -2. How we doing? We good? Okay. Here we go. So here we have a piecewise function. We want to integrate this from -3 to 2. But we have 2 different pieces that make up one function, right? This piece, this linear piece, so I have a line for everything that is less than 0. I have a quadratic anytime x is greater than 0. So basically, I have 2 parts to integrate, 2 different things. I only need to go from -3 to 2, but I got a break in here at 0. So I can integrate from -3 to 0, and then from 0 to 2. Yes. So from -3 to 0, do I use the top piece or the bottom piece? The top one, because it's less than 0, right? So this is, and I need parentheses, x plus 1 dx. Plus, then I'm going to integrate from 0 to 2, the other piece for when it's greater than 0, and it's going to be x squared plus 1 dx. Okay. We good with that? What questions you got?
That's it?
Well, no, we're not finished. Sorry, we're not finished. Do I need to use substitution here?
No.
No. Technically on this one you kind of could, but it'd be weird and you don't need to. Here, if you tried, it wouldn't work out, but I can do each piece, and so I don't need to. I don't have a product. I don't have a quotient. It's not a function inside of a function. So I'm just going to integrate. When I integrate this, I'm going to have, let's see, that's going to be x squared over 2 plus x, right? evaluated from -3 to 0. Yeah, because you didn't have to do the plus c because we're not just leaving it. Yeah. Plus, then when I do this one, I'll get x cubed over 3 plus x evaluated from 0 to 2. So there's actually like 4 pieces here because I got to do this one minus this one, and then this one minus this one, right? So I start with, it's the top minus the bottom. When I substitute 0 in here, it's just all 0, right? Not a bad idea to write it because it's 0 minus. And so you want to make sure you don't mess up on signs here, right? -3 squared is what? 9. So this will be minus 9 halves. But I've got parentheses here because there's 2 things. And then when I substitute this in here, it's -3. So these are the 2 pieces from that first section. Plus, then I'm going to do this one. So I start up here. You start with the top. So 2 cubed is 8. So that's 8 divided by 3 plus 2 minus, then we substitute in this one, and that's just all 0. So no, you don't have to write the zeros, but I'm afraid if we don't here, we might mess up on our signs. You with me? So this gives me, so this is equal to -9 halves plus 3 plus 8 thirds plus 2. That's a safe stop. But if this was multiple choice, we'd have to get a common denominator. What's our common denominator? 6, yeah. So 6, which means I'd multiply this by 3, so I'd have -27 over 6 plus 18 over 6 plus 16 over 6 plus 12 over 6. Ew. So let's see, let's do it this the easy way. 12 and 18 is 30, right? And then I subtract 27, I get 3. And then I add 16, and I get 19 over 6. Think smarter, not harder. Okay. Instead of just going from left, you can go from left to right, but that's yucky. I look at whatever makes the most sense quickly. All right. You try this last example from the AP exam here. Yes, x times e to the x squared.
What's e to the 0?
What's anything to the 0 power?
1. I knew that too.
Good. When x equals 4, you're substituting it into here, not the original. Okay? Does that make sense? Negative come from. picking stuff up. Okay, but you have this x. You shouldn't have e's and or x's and u's together. Yeah. I'll be there. You'll see me. Well, I don't know. She didn't guarantee that y'all were going to be in my sessions, but I don't know. Mm-hmm. Oh, you're not going to be stressing. Look, all right, let's work through this together. So I saw over here, there were some people that picked the wrong U first, right? Did you pick the wrong U first?
Yes.
You did. Okay, that's going to happen. It's going to happen. At least you're trying something. So when you do that, and you're like, ooh, can't use that. So then if there's something in the exponent that's not just a number, then that's usually what we try. So we'll say, all right, well, U is going to equal x squared. So du equals 2x dx. Then I'm also going to look at my limits. When x equals 0, right, my u equals, thank you, equals 0, my brain was like, when x equals 4, then I'm substituting it in here, u equals 16, okay? So when I was working through this problem, I went, all right, so I know my limits, and this is all in u's, so I know I'm going from 0 to 16, so it can't be any of those, right? Just some test taking stuff. Huh? Actually, I think I did the first time I did it too. Sometimes I do those first, and sometimes I write the integral first. It kind of just depends. But so I have 2x dx, so I did have to put in a 2 and then a 1/2. And so then that is when I can go, all right, I have to have a 1/2 outside, so my answer has to be B. I didn't even really finish it. So this would just be 1/2 times the integral from 0 to 16. This 2x dx is taken care of by du, and then I just have e to the u du. We good? What questions you got? All right, y'all do the first couple on your assignment. Yes. Good. Have you had a great day? Oh, I'm sorry. It was my class.